Hi and welcome to today's session on iteration, which is just another name for trial and improvement. So when we are talking about iteration, we are talking about a method which is going to start off at one point, maybe not have the complete solution, and keep trying until we get closer and closer to the solution. So it's a form of approximating where a lot of times when these crop up in questions, we aren't going to find the exact value, but we're going to find the solution which is closest to the exact value. So as an example, we've got x cubed plus x equals 105, where the solution is between 4 and 5, and we've got to give our answer to one decimal point. So first thing I'm going to try is when x equals 4, because my solution is between 4 and 5. So I want to check if 4 and 5 are actually part of the solution. So replacing x by 4, substituting my 4 in, I've got 4 cubed plus 4, which gives me 68, which is not 105. I'm going to try 5. 5 cubed plus 5, that gives me 130, which is too large. So the best way that I can try and show my results is by putting it into a table. That way it's nicely set out and it's easy to follow. I've already got my 4 and 5 in there. I've got my 65 in red because I'm just showing that that is too low. And the green is just showing that the answer is too high. So after I've tried my 4 and 5, I'm going to try 4.5. Substituting in 4.5 into my equation, I get 95.65. I've tried 4.5 because I want to see if my answer is closer to 4 or closer to 5. Now, because my 4.5 is too low, I know that now my answer is between 4.5 and 5. Now, my logical side, I will try a number right in between these two numbers. But many learners, they'll try 4.7, 4.6, 4.8, 4.9, and just try and arrive at the answer through those. So the 4.75, that gives me an answer of 111.921875, and this is too high. So this is telling me the answer is between 4.5 and 4.75. I'm going to try 4.6 because my answer is to one decimal point, so trying single decimals, just concentrating on tenths rather than hundredths, that seems a bit more logical. Trying 4.6, that gives me 101.936, which is too low. I'm going to try next one up, 4.7, because if 4.6 was too low, 4.75 was too low, I'm going to now try 4.7. And 4.7 is too high at 108.523. Because bear in mind, we are looking for our answer to be closest to 105. But we've got to give our answer to one decimal point, so one of these is going to be the closest answer. The easiest way to find that is to try the number right in the middle of these two, so 4.65. Putting 4.65 into the equation gives me 105.194625, and this is too high. Now, some of you may already recognise which is the correct answer, but just to clarify, I've used an approximation sign, so x is approximately 4.6 to one decimal point. That's because our end solution is closer to 4.6 than it is 4.7. A little visual for that. Here I've got 4.6, here I've got 4.7, and here I've got 4.65, where 4.65 was just too high, and 105 is roughly about this position, so it's closer to 4.6 than it is to 4.7. If you like what you see, please subscribe. Thank you very much for watching.